Good morning. Welcome to our next stats lesson. Today I want to talk to you about distributions and histograms, and as we talk about that, I would like us to focus on a particular idea. Last time we talked about collecting data, and we discussed different ways that would work well, random samples. This time we want to take that data we've collected and figure out how to organize it to start making sense of what's happening. But as we organize it, I want to keep two things in mind. One, the way I choose to organize something might be a little different than the way you choose to organize it. So we're going to need to come up with some standards so that hopefully you and I would be able to organize things similarly. And two, I want to think about this. It would be very easy to put these numbers into a program like Excel, and in fact, I strongly recommend that you do. Learn to become comfortable with Excel. Learn to become comfortable with computers. They organize data for us so well. However, when you're just starting out trying to think some new ideas, remember last time I compared Russian to English with glasses versus mugs, and the organization structure. When you're starting something new, it's very useful to get your hands dirty. Calculate things a piece at a time. Plug stuff into equations and scribble on paper. Use a calculator. And for most of my lessons here, I'm going to be using my TI-36X Pro, which I selected because it was cheap and it will do stats for us reasonably well with small numbers. Realize that we live now today in a world of big data. And I mean enormous. Every minute on YouTube, days worth of content is uploaded. Every hour on the internet, words and paragraphs, an insane amount of data is created. Walmart is able to track the difference between the ivory soap they sell you in front and the ivory soap they sell you behind. There is an immense amount of data we've got, and it's different than it ever was before in the history of ever. 400 years ago, data was difficult to find. 20 years ago, data was difficult to find. Today, one of the best life skills I could recommend you learn is how to ignore things, not how to find things, because you have to decide how to ignore that friend's stupid Facebook post, and you have to decide how to ignore thousands of videos on YouTube that I'm never going to watch. How do I know which ones are important and which ones aren't? That's a complicated process. So get your hands dirty with these small examples so that when you're ready to use computers to power through the big ones, you have a sense of what's happening. So let's take a look at this. I've got salaries at a company, some random company that I picked. These salaries are in thousands of dollars, so I say 22, and you know I mean 22,000. And what I would like to do is organize this in some fashion so that I can get a sense for how do these salaries work. Notice some nice things about my numbers. They're already organized from low to high. If they weren't, that'd be okay. I'd type them into Excel and hit the sort feature on the far right, and good things would happen for me. Get comfortable with that sort feature. Not all of our data comes to us so nicely organized. Here's what we want to do. We want to sort this data, first of all, into bins. Think of any time you've ever signed up for something, and there's a very nice lady usually sitting at a table, and she's got a stack of folders. And you go up to her and you tell her your last name. And then she knows which folder, the A through D folder or the E through F folder, and goes on through. We want to do that with numbers. So what we would like to do is to sort these numbers into bins. We call those bins classes, and we can choose how many classes we want. Now, if I sort things into just two classes, that seems kind of silly. Why don't I just keep them in one? And if I sorted them into 50 classes, that would also seem kind of silly because I haven't made the problem any simpler. There's still 50 different things I have to sort through. So instead, we have the conventional wisdom that the number of classes should be between 5 and 20. That is entirely arbitrary. It could be 4 to 21, or it could be 6 to 22. Who cares? The point is, we've chosen to go between 5 and 20 because that seemed to make sense. And 5 and 20 are nice numbers. So when you're organizing your numbers into categories, just like when you do last name and use alphabetical order, you have to make sure that every number has a place to go. The way we're going to do that is with class width. We're going to take our largest numbers, subtract the smallest, and divide by the number of classes we want. So we can definitely grab our largest number here, 22. Excuse me, 22 is my smallest number. We can pick our largest number here, 180. Probably the CEO of the company, making just a little bit more. This looks like a small company, so I'm going to say that this is probably the CEO/owner. And as we're taking that, we then have to decide the number of classes we're going to divide by. And that's entirely up to us in general. What do I mean by in general? Well, obviously some of our homework problems will say do it in 6 classes, and then you better not do in general. You better do 6. I think for us that dividing it into 6 classes is probably just a perfectly fine idea. So I'm going to choose 6. Here in this problem, I'm picking the number. I get to do that. Some problems you'll get to pick the number of classes. Others, the number of classes wanted will be told to you. I'm going to divide this by 6. And if I do pop that into my calculator here, just to make sure I get it right, it's telling me 26 plus a third. I'm not going to write 26 plus a third because it would be really odd to start talking about thirds when none of my numbers involve thirds. However, I do want to read step 2 of this process. First, take the largest minus the smallest and divide by 6. Next, step 2, increase to the next highest whole number. Take a second to think about that. 26.33, and you should probably grab your calculator out and do 180 minus 22 divided by 6. Follow along with me as much as you can. It'll help. Get your hands dirty. I'm getting 26.33, and maybe you can see that here on my calculator. This doesn't say round, because if I round it in the normal way, I would round this to 26, right? But this says increase to the next highest whole number. In statistics, we tend to be a little more subtle with how we round things. So watch carefully. This is one of about 7 different ways we'll choose to round stuff. Increase to the next highest whole number means I have 26.3. I relabel this 27. Make sure you do that and understand that. I don't use equals here because they're not equal. This number on the right is 26.333333 repeating. This number on the left is 27. Those aren't the same number. You use wiggly equals anytime you do a rounding. That lets you and me both know if we're looking over your work sometime, this is a rounding process that was going on. And then we just have to make sure we've done the right one. This is called my class width. It's how wide my folders are to put all these different numbers into. That's nice. I know I'm going to have 6 folders because that's how many classes I've got. So we start to be able to organize this data. We can have class, and we'll have the first, second, third, fourth, fifth, and sixth class. Next, we want to start sorting our numbers into these groups. And the way we're going to do that is we're going to talk about class limits. There's the lower limit, and there's the upper limit. The lower limit is the smallest number that's actually in the class. And in general, for the first class, my first lowest limit will be my smallest number. You might decide to choose 20. That would be understandable. It makes it a nice round number. Either way, we're going to get about the same kind of information here. Once we've got the lowest class limit, the class width, this number 27 here, is going to be the ways that we move from number to number. So if my lower limit of the first class is 22, and my width for each class is 27, the lower limit of the second class is going to be 22 plus 27. This 22 plus this 27. Again, just to make sure I'm doing things right, I'll do this here on my calculator. And suddenly I'm realizing one of the reasons why I'm almost entirely unable to see. I need my glasses. 22 plus 27 gives me 49. To find the lower limit of my third class, I'm going to take this 49 plus this 27 and do it again. And if you're using this calculator, which I strongly recommend because it's the only one we allow on our midterm and final, just hit plus, and it takes your old answer, and then you can just hit 27 again and hit enter, and suddenly you've got yourself your next one. So be efficient with your calculator. Learn to be comfortable with it. Learn to use your calculator with the examples in the textbook, not the exercises, the examples. That way you know that you're doing the right stuff. Sort of calculator calibrating, I call it. My next one is going to be 76 plus another 27. Again, I just hit plus 27, and I get 103. And then I do 103 plus 27 again, and I get 130. And I do 130 plus 27 again, and I get 157. And this gives me the lower limit of my 6th class. Now my upper limit is going to be the highest data value that can actually fit here. It's going to be one smaller than the next higher class's lower limit. Pause and rewind that. The upper limit of class 1 is going to be one number smaller than the lower limit of class 2. 48, because it's 49 minus 1. 75, 102, 129, 156. Uh-oh. I don't know what this one is. That's okay. We can cope. I could take 157, add 27 to it one more time. If we had a 7th class, I'd have 184. So I know 183 should be my upper limit. These are the limits. Limits are actual numbers that can fit. So since I had integer data, nice whole numbers there, then I knew my limits were going to be integers. Next, we have boundaries. And boundaries are half a decimal place in either direction around the limits. So you'll have both a low boundary and an upper boundary. 22 minus a half will give me 21.5. Figure out how I did that. 22 minus 0.5 gives me 21.5. 48 plus a half gives me 48.5. 49 minus a half gives me 48.5. Notice these two numbers match. They're supposed to. Boundaries are not limits. Limits are actual numbers that can fit inside the classes. Boundaries are the walls between. Think of walls between two classrooms. The limits are the students who can sit in the seats, and the walls, no one can actually sit on the wall. So we're a little bit further, 0.5 and 0.5. You'd never find a number here that was 0.5. Notice this is for whole number examples. If my numbers were things like 22.5, then my boundary would be 0.05. 75.5, it's really easy to add up on that upper boundary. 102.5, 129.5, 156.5, 183.5, and since these diagonals always stay the same, that maybe is easier than subtracting 0.5 from each of these. 129.5, 156.5. Now I've got my boundaries. The next thing that we tend to do is we tend to start counting frequency. It's time to sort. I see how many numbers fit between 22 and 48. As I count them in, I'm going to cross them off with this red color here. So I have 22. That's one. I've got 23. That's another one. Any number between 22 and 48. I've got 22 here. 48 is going to stop here. So I have 1, 2, 3, 4, 5. Maybe every 5 I'm going to do a cross here so it's easy to count. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. So 12. 12 of the salaries fall into the first class. All right, let's carry on with this. 49 to 75. 70, this is bigger than 75, so I've got these numbers in here. 1, 2, 3, 4, 5. 1, 2, 3, 5, 6, 7, 8. I've got 8 in this class. 76 to 102. 1, 2, 3, 4. 103 to 129. None. 130 to 156. None. 157 to 183. Exactly 1. Notice what this grouping has done. We could see it from the raw numbers a little bit, but now it's there in black and white. Most employees make between $22,000 and $48,000. 12 of them do. There's lots of employees who make between 49 and 75. This does not seem to be a poor company. There's even some folks who make in the low 6 figures. But then there's this vast gulf. There's a very big difference between this person and this person's salary. Now, I've said this is possibly a small company, so quite possibly we're looking at some sort of CEO/owner. But the point is, when we organize the numbers this way, we start to see that there is a difference between some of these numbers. We start to notice that that $180,000 is different from all the rest. Let's keep up with this. I'll point out just for the moment that the midpoint is the middle spot in any particular class, and what you do is you take the upper and lower class limit, add them together and divide by 2, and that tells you the midpoint of a class. So let's do that on this chart just because, and let me go ahead and erase some of this stuff. Let's see here. I guess I can safely erase class width. You remember how to do that? Now's a brilliant time to mention that your textbook comes with a formula cheat sheet. That formula cheat sheet is yours to have on the midterm and the final. There can't be anything else written on it. And for my students, online or face-to-face, I have a laminated copy of that will be available for you when you're taking your midterm and final, just to make sure that there's no encouragement to secretly code little messages to yourself. But that formula cheat sheet is yours to keep. I don't expect you to memorize formulas. I expect you to know how to use them, which is actually a lot harder. Don't cheer my name because I'm giving you that cheat sheet. Class midpoint. The midpoint is a good solid number to describe any particular class. Go ahead and get rid of this class frequency as well. We'll calculate that out in a second here. Alright, class midpoint. You take the lower limit plus the upper limit and divide by 2. So I take 22 plus 48 and divide that 70 by 2. And I get 35. Class midpoint is a really nice number to have because it gives you one single number to describe this group of people. Kind of like almost an average salary. Not really, but kind of. $49 plus 75. Let me go ahead and show you something here that I'm going to do on my calculator for calculations like this. Notice that there's this little fraction button here, so I can hit that, and on the top then I can type 49 plus 75. And then I can scroll down, and then I can type in 2. If I scroll to the side and hit enter, this will give me an answer, in this case 62. I can keep on doing that, and I don't always have to do that, of course, but maybe it's easier than adding the two numbers together and dividing. And anyway, it's a nice feature in your calculator for some later stuff we do. I can keep on calculating this. 76 plus 102 divided by 2 gives me 89. 103 plus 129 divided by 2 Be careful. Make sure if you're going to not do the fraction bar thing, that you do 103 plus 129, hit enter, and then divide by 2. Otherwise, your calculator might give you something that's not true. Be careful with your order of operations as you calculate things out. 116, 130 plus 156 divided by 2 gives me 143. And finally, in our owner CEO category, 170. These are the midpoints. They're going to be useful for some of the graphs that we're going to talk about. Okay, we've got midpoints, we've got frequency. There's one last thing I'm going to do. It's called relative frequency, and then I will have my table done. REL, frequency. Incidentally, if you've ever used Excel, and now you should start if you haven't before, you can see how Excel could be very powerful in making this happen quite nicely. But again, getting our hands dirty. In my case, quite literally with these markers. Relative frequency takes the head count of frequency in a particular class and divides by the total number of people. Here we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. We've got 25 folks total in our company. So the relative frequency is always going to be divided by 25. And then I just take the actual frequency count and put it on top. 4, 0, 0, 1. And then we just calculate out what all of these equal. And of course 0 divided by anything is going to be 0, so there's nothing here. But I can calculate 12 divided by 25. And this gives me 0.48. Notice that relative frequencies are numbers that live between 0 and 1. They're decimals. And you can convert those decimals to percents. So this tells me right away that it's not just 12 people who live in this category, but almost half the company lives in class 1. 8 divided by 25. 32. 0.32. 32% of the company lives in class 2. If I was to add these together, I would start to say most folks earn salaries that look like 35K or 62K. That's the general salary group that folks seem to be sorted into if they get hired in this company. And that's interesting. 4 over 25. 0.16. And finally, of course, 1 divided by 25. 4%. The company is earning in this high 100K range. This is my table. It's very interesting, but maybe it's not quite so interesting to look at. It's not a picture. And pictures really are worth, to use the pithy cliche, 1,000 words. So let's go ahead and talk about histograms. Histograms are a great way to draw things out. Now that I have my table down here that I've cooked up, now that we've got this frequency distribution table with all the classes, I'm going to go ahead and erase my raw data. It's time for this to go away. I'll draw my picture up here so we can see how it's going. And if you take a peek in your textbook, you can definitely find a list of steps for how to draw a histogram. But the basic idea is this. For a histogram, you make your relative frequency table. And there's two types of histograms that you could discuss. You could have one based on actual frequency, or you could have one based on relative frequency. What's the difference? Well, there's not a big difference, other than the fact that here we preserve the raw head counts, and here we're sort of converting everything so we can compare apples to oranges. This is percents. If I wanted to compare this small company to, let's say, a very large company like Microsoft, maybe it would be difficult for me if I was using these head counts because Microsoft will probably have thousands of employees in this range. But if I convert it to percents, maybe I'll say, you know what, this company's behaving quite a lot like Microsoft. The percents of the employees in these salary ranges are exactly like Microsoft percents. So think about that. Frequency versus relative frequency. Either way, with a histogram, we're going to have some stuff. On the top, maybe the y-axis that we're used to, you're going to either have frequency count or relative frequency count. I'm going to go ahead and draw both. This one will be a frequency, and this one will be a relative frequency. And notice the first thing that I've done. I have labeled my axes. It is impossible to overemphasize how terribly important it is that you label things properly, because unlabeled and mislabeled graphs are the first sign that someone's trying to lie to you with statistics. They stop labeling things. I remember always this news article I read, I don't know, it must have been almost 10 years ago now. It was from Colorado, and they said this: teen pregnancy drops off drastically after 20. Think about that. I read that headline and I thought, well, absolutely. In fact, I suspect that teen pregnancy drops to 0 after 20, because it's no longer teen pregnancy, it's 20 pregnancy. Now that's just a silly headline. But I also once heard, not in my current state, but I heard my representative to the U.S. Congress, my U.S. representative, get on TV in a, not quite a debate, but a discussion he was having on the local TV channel, and look everyone in the eye and say, half of our children read below average. And he said, I won't tolerate this. And of course, again, I'm sitting there, now that was like 13 years ago now, I'm sitting there and thinking, actually, you're going to have to tolerate that because average is the middle. Half are above, half are below. Now, later on, we're going to talk a little bit more about average, and there's a couple things he possibly meant. But either way, it wasn't very good. Label your graphs. It's a sign of honesty. And honesty and ethics are in short supply in our world. Next, you should label your x-axis. And your x-axis for histograms are going to be based on the boundaries. So these boundary calculations were really important because that's how we make a histogram. If we didn't use boundaries, we wouldn't call them histograms. So my boundaries go from 21 to 48.5. Um, 75.5. I'm going to need just a little bit more space to make this all work, so we're going to have to hold off on this relative frequency one for just a bit. 75.5, 102.5, 129.5, and 156.5. And of course the next one bigger, which will be 183.5. This is my x-axis. Those are the little tick marks that I've drawn. Watch carefully what I do here. I'm going to put a squiggle. It just looks like I've drawn a couple little, I don't know, some kind of M-shaped thing. That squiggle lets me know that this might not be drawn to scale. There might be a distance of 27 between all of these, but there's not a distance of 27 here. It's another sign of honesty. If your graph doesn't have that, and yet it's not drawn to scale, then you're kind of trying to deceive people just a little bit. All right. We're doing frequency here. I've got my different counts. The highest one's 12, so I think I can probably go 2, 4, 6, 8, 10, and 12. Notice on the y-axis, I didn't need to draw a squiggle because I've done this all in distances of 2's. This right here can be 0, and I can definitely count up by 2's there. Now it's time to draw. In histograms, what you do is you find your class that you're talking about, and since this is a frequency histogram, we're going to pick this 12, and I'm going to go from here, and I'm going to draw up to height 12, and I'm going to go over here, and I'm going to come down. And then you shade this in. For my second class, we've got a height 8, Notice I draw these right so they're all touching and they're on the boundaries. For my third class, I've got height 4. I'm just shading this in so it looks pretty. For these classes, we've got nothing. We've got height 0. And then for this one, we've got height 1, so I'm going to try to come about halfway through here. Draw this guy up there. Shade him in. This is the histogram for this company. This is the shape. And if we had a relative frequency histogram, there's only one little change we'd do. We'd label this R frequency, and instead of having these numbers on the y-axis, we would change those numbers to these decimal points, and that would be it. So the shape, if you sort of zoom out, would look exactly the same. But once we have this histogram, we can talk about some pretty interesting things, because we're able to talk about the different shapes. So go ahead and rewind if you want to. See how I took the raw data that we collected on salaries, turned it into this frequency distribution, turned that using the upper and lower boundaries and the heights into a frequency histogram, and now I'm going to draw some different shapes of some other histograms so we can focus on types of data, because we've got a very specific thing. To do that, I'm going to have to erase our table here. This histogram that I've drawn shows very nicely what's happening with the salaries. It definitely shows me that most of the workers are paid the lowest salaries. And as the salaries increase, I hire fewer and fewer workers at that price point. It also shows me something else. This guy right here is what we call an outlier. This one is not like the others. It's different, drastically different in this case. There's different types of histograms that you could have. I'll try to draw up a couple here. We've got this one here. We could have one that looks a little bit opposite. This one sort of starts high and trails off as you go from left to right. This one starts low and gets bigger. I'm not a great artist. This one starts small, gets big, and goes small again. Then I could have, I don't know, a couple others here. Let's see. Have something totally flat looking. We don't normally draw these sides of the histogram all that much. I'm just used to an XY axis maybe. And then I could have something that looks like this maybe. So this is an outlier. He's a little different than the others, and we'll talk more and more about outliers as we carry on through this course. But these different histograms have some of these different properties. This one right here is called mound shape. That describes its shape, but we have a better word for that. We call this normal. If you start out small, get more people, and then get small again. That's called normal, and it is the most interesting shape that we've got. Think of what would happen if you started counting all your friends and you were measuring them by height. You probably, like me, have a few friends who are very little. And then you have some more friends who are just a little bit shorter than normal. Then you've got the most friends who are about the normal height for your group of friends. And then you have a few friends who are a little taller than you. And then everyone has that one friend who probably had MBA dreams at some point because they were very tall. Remember, the y-axis generally is talking about number of people. And the x-axis is generally talking about amounts. So you tend to have frequency and amounts. So this is how many people were of normal height. And most people are average height. It's very rare that you walk around and see somebody who looks like Shaquille O'Neal. It's very rare that you walk around and see someone who looks like Peter Dinklage. Mound shape is normal, and it is a biological phenomena, it is a cultural phenomena. Most things that behave well behave normally. So I said we talk about statistics because this is a statistics class. And from our discussion last time, you know now that that means we're going to be looking at sample data a lot. And we're going to use that sample data to project it onto the population. I'll tell you something else. We're in this class talking about normal statistics. Pretty much from here on out, we're only going to have a very few examples that don't behave in this normal fashion. And if they do, we're going to properly label them for you. We'll make a big deal about labels in this class because it's an intro stats course, so you'll tend to see me say, this is normal data, this is normal data, this is normal data. What do I mean? I mean that it starts out with very few people, in the middle it has the most, and it goes down from there. But let's talk about unnormal data. These types of charts, where it's not normal, these are called skews. In particular, skew means tail, so you look at which side the tail is trailing off on. In this case, the tail is trailing off in the right direction, so sometimes this would be called right skewed. But it could also, because this is the positive x-axis, this could be called positively skewed. Similarly, this could be called left skewed, but because this is the direction towards the negative x-axis, we could call this one a negative skew. Notice those words carefully. Once somebody observed that there's lies, damn lies, and statistics. I've also heard this class called statistics, and for good reason. Now I will tell you this, numbers don't lie. People lie. But people who don't understand numbers can be lied to. And that is one of the biggest reasons for you to be taking this class. Don't let people lie to you. Right here, this company, it's a perfectly fine company. I know plenty of people who would be very happy to be earning median scores of 35 or 46K a year. That's lovely. It's great. But the fact is, this company is a little bit odd. Now, it's not odd as a company. I'm saying it's a little bit odd in terms of our idea of normal. It's skewed, but it's positively skewed. And if I walk up to you and you're interviewing, and I come in and say to you, you know what? I like you. I like the work you're going to do for my company, and I just want to let you personally know that our salaries here are positively skewed. And I smile. You're happy. I just said the word positive. That's a good thing. Unless I'm hiring you as the CEO, that's probably not a good thing, because probably what I'm secretly telling you is everyone starts out at the bottom rung of labor wages. And you're going to have to fight and claw your way to the top. I could say this about class grades. F's, B's, C's. Oh, look, there's the A's. But if I stand up in front of my board of trustees here at the school and say, not to worry, folks, my grade distribution is positively skewed. And then I walk off. They're going to be like, heck yeah, look at that happy dude. He's teaching statistics, he's got things positive, everything's under control. On the flip side, if I had a grade distribution like this and I'm pretty much passing everyone with a pulse, which just fair warning I don't do, I might walk up in front of the board and say, my results are negatively skewed. And they would be like, that doesn't sound so good. There's nothing wrong with positive or negative. They can be good things or bad things. Be careful. We don't mean positive or negative in terms of the amount of happiness. We mean positive or negative in terms of Does it trail off on the plus side, or does it trail off on the minus side? So positive or negative skewing. These two are skewed. This one's normal. This one right here looks like two copies of a normal. This is called bimodal. Bi meaning two. There's two different groups of normal pasted right together. There's one group and another. And in all honesty, most classes I teach tend to look like this. Students who follow all the instructions, they read the textbook, they watch the videos, they do the homework, they do the extra suggested exercises, and come to office hours, you're going to look like here, and you're going to have A, B's, and C's, and everything's going to be happy for you. This is the cottontail bunnies in Peter Rabbit. They had bread and milk and blackberries for dinner. Students who don't read the book and don't show up to class and don't do the homework and don't show up to the exams, bad things happen over here. And lastly, of course, you could have some type of uniform information here. Everybody somehow seems to be leveled out. This would be what would happen if I tried to level out the number of students in different classrooms. Of course it's pretty level because all the classrooms have a certain number of seats and we like to fill those seats. So it would be very uniform, not normal, just very strange and boring. This is the stuff we're interested in talking about. This is the stuff we're excited about. This is the stuff we would like. There's a couple of other charts and graphs that you can look at this section. You can look at an ogive. That can be interesting enough. Ogive is how that's pronounced. It's interesting, it's useful, you've got a couple of homework problems on it. It's not, once you've drawn the histogram curves, particularly difficult. I don't tend to see all that many ogives. They exist, of course, people use them, but it's maybe not quite as popular as some of the more exciting graph models possible. And I'm not saying histograms are exciting. What I am saying is that if you can draw a histogram with the raw data, then you can understand, you've done enough of getting your hands dirty, and any other fancy graph types you can probably work out. So, I think that I'm going to leave Ogive for you to take a look at. I'm also going to leave a relative frequency and a cumulative frequency histogram for you to draw. And I'm going to leave you here, and I will find you in the next section. So study hard, read your book, and remember,